Use the squeeze theorem to find the limit as x approaches 0 of x squared times cosine of 1 over x squared. Now, evaluating this limit directly is a little bit difficult because this cosine of 1 over x squared ends up being a bit weird as x approaches 0. We end up having a situation similar to what we did with the sine of 1 over x, where it was oscillating more and more and more as we approached 0. But here's the thing, we know that cosine is a function that is bounded between -1 and 1, right? We know that cosine of anything, specifically cosine of 1 over x squared, has to be between -1 and 1, at least wherever it's defined. This is not defined for x equals 0 because we would have an undefined quantity inside. But because we're looking at the limit as x approaches 0, we care about what's happening near 0, but not at that value exactly. So we can ignore x equals 0, and everywhere else, this inequality is true. And then if we multiply all of these by x squared, that tells us that -x squared is less than or equal to x squared cosine of 1 over x squared, which is less than or equal to x squared. Now, we do have to be careful when we have an inequality and we're multiplying by something, because we know that when we multiply by a negative, the inequality sign has to flip. But because we've multiplied everything by x squared, and x squared can't be negative, that means that we do not have any changes in the inequality signs. And once we have this inequality, these are our functions for the squeeze theorem. The lower function, f of x, is -x squared. The higher function, h of x, is positive x squared. And then the middle function, g of x, is exactly the function that we are taking the limit of. So we know that our function is bounded or squeezed between -x squared and positive x squared. So if both of these functions have the same limit as x approaches 0, then that tells us that our function has that same limit. So let's explore these. Let's look at the limit as x approaches 0 of x squared, and the limit as x approaches 0 of -x squared. Now, both of these are polynomials, so we can use the direct substitution property. 0 squared is 0, and the opposite of 0 squared is also 0. So because our function is squeezed in between these two functions, and both of them have a limit of 0 as x approaches 0, that means that the squeeze theorem tells us that the limit as x approaches 0 of the middle function, x squared cosine 1 over x squared, must also be equal to 0. So that is our limit. If you want to see what this looks like, I encourage you to go to an online graphing calculator, or if you have a physical graphing calculator, of course you can use that, and graph these three functions and see exactly what's going on near x equals 0.